Hi there, welcome to Machine Bytes, your go to place to learn AI the smart way. Today's topic is set theory. Set in programming languages is a kind of data structure. In this video, we will learn about the basic idea behind sets. Let's first understand what a set is. Set is the collection of unique elements. This means we will have some number of items in a set which are unique in nature. If I say 1, 2, 3, 2, this collection of elements is not a set. Why? Because 2 is appearing twice. Now, if same set of elements is represented like 1, 2, and 3, then it will be called a set. Other property of set is that elements are not ordered. This means that if we have a set like this, 1, 2, 3, we can't fetch the element at third place, which is 3. So we cannot pass the index of a particular element and fetch that. There is no indexing done to the elements of a set. There is one other term associated with sets, which is cardinality. Cardinality is number of elements in a set. If set A is having values like 1, 2, 3, then cardinality of A denoted like this will be 3. Let's understand what all operations can be performed on sets. The first operation is union. If we have two sets like A with values 1, 2, 3, 4, and B with values 3, 4, and 5, then union of A and B, denoted like this, will be the combination of all unique elements. That will be 1, 2, 3, 4 from set A, and then only 5 will be taken from set B because 3 and 4 are already there. If we want to represent this in a picture, it will be something like this. If this is a set A, this is set B. So our set A has values like 1, 2, 3, 4, and set B has values 3, 4, and 5. So in this case, the union will be all this area. The next operation is intersection. Let's take example of the same sets. In this case, intersection of A and B denoted like this will be all the common elements between set A and B. In this case, it will be 3, 4. These two elements are common in both the sets, hence this will be the intersection of 3 and 4. If we want to visualize that, this area is the intersection of A and B. The next operation is difference. It is denoted like A slash B, or simply we can say A minus B. This will have elements of A which are not in B. A minus B in our case will be elements of A which are not in B. So that will be 1, 2 only. If we want to visualize this, then A minus B will be this area. The next operation is symmetric difference. Symmetric difference is denoted by a cap symbol B. This will contain elements which are either in A or in B but not both. If we want to visualize this, then if this is set A, this is set B, then asymmetric difference B will be elements which are in either A, this area, or B, this area, but not in both. So this area in the middle will not be considered in asymmetric difference B. The other operation is subset or superset. It is denoted by A subset of B. So A will be subset of B if for every element, say small a, in set A belongs to set B. Its visualization will be like if this is set A and this is set B. In this case, every element in set A, say if there is 1 and 2 here and 3 and 4 here. So 1 and 2 are elements of A as well as of B. We can say that A is subset of B. Here, A is subset of B. Or we can also say that B is superset of A. There is one more operation where we calculate the complement of a particular set. Complement of A will be denoted like this. Will be all the elements from universal set which are not there in A. If we have a universal set U of containing all natural numbers, and then we have a set A containing all even numbers, then complement of A will be this area, which we can say it will be universal set minus A. That will be all the odd numbers. These are some of major operations that are performed on the sets. Now let's understand when can we use sets in our AI applications. Sets can be used to compare feature values between datasets. The other uses is to clean or standardize the data. This can be done for categorical data, where we have some predefined classes which can take the values in those particular columns. The other uses can be to detect unseen categories. Now, if we have standardized our data in step 2, we can detect the unseen categories which were not seen in step 2, and this can be done while predicting new values. The other uses is to remove the duplicate entries, since sets can only contain unique values. In NLP, that is natural language processing, where we mostly work with textual data, sets can be used to find common or unique words. These are the sum of basic features and uses of sets. In upcoming videos, we will see the practical implementation of the sets. That's all for this video. If you have any questions, doubts, or suggestions, please do let me know in the comment section below. Thank you so much. Bye bye. Take care.